I'm going to talk a little bit about migration. And first of all, disclosure, I work as an independent consultant, and I work with NGOs, and I work with the private sector, and I have been pestering the FDA, the Food and Drug Administration, to change its ways in the last 9 years. So, again, packaging. We are talking about all this, but I want to give you another one that is, we cannot forget about all the chemicals that come into food through the manufacturing process. So now we are talking about the final packaging, but there are a lot of other things happening before the food gets into the final packaging. So, again, packaging is good for protecting the food, prevent contaminations, environmental contamination, microbial contamination, and to increase the shelf life of products. But this is the issue that we are talking about today. Jane showed you this graphic. Here is represented more clearly with things that we know about the material, the food contact substances, and then I have a list here of some of the chemicals that are already known. Most of them are organic chemicals that are used in the manufacturing of these materials. In the U.S., this is probably approximately 5,000 chemicals that the FDA has cleared and approved for use in packaging. As Birgit said, we don't know how many of those are actually in use, but there are at least 5,000 that the FDA cleared for use. And then we have also inorganic elements that are part of packaging and materials. So all this is fine and good. The issue is that packaging is not inert, that there are exchanges happening there, that chemicals move from one place to another one. And that is what I want to focus on today, because if we want to reduce exposure to chemicals, we need to understand how those chemicals get into the food so we can prevent that from happening. So very quickly, we are going to go on a quick ride, and bear with me on this, because we have little time, on discussing migration. So there are different factors that affect chemicals moving from the packaging into the food. One of them is the chemistry. So the strength of the bonds keeping these chemicals together is important. The stronger the bonds, the least migration occurs. Again, the opposite is true. If the chemicals are not bound together, they move out very quickly and they get into the food very easily. So the two ends of this spectrum would be examples like Teflon and glass. Those chemical bonds are strong. The migration is relatively low of chemicals out of these materials. On the other end of the spectrum would be PVC, that is it itself, the polyvinyl chloride is a hard chemical. It needs plasticizers added to it to make it flexible and malleable. Among those plasticizers, the most common and famous are phthalates. So phthalates are not bound. They're not chemically bound to the plastic, so they come off. That's why they are everywhere, in your house dust, in your food, in your drink, in the air. So another way that chemicals can get into the food is through the manufacturing process. This is an example for BPA, for instance. When BPA is used to make the lining of the cans, it's used in two different steps, at the beginning and then in the middle. So to make this polymer, you need links. These are links that then form big chains that are called polymers. So you use BPA twice to make the purple material there, and then you add more BPA to keep increasing the length and the complexity of the final polymer. Now, if the BPA doesn't react, all of it that is added to the product, there is lingering BPA at the end. And that BPA sticks around and is what it gets into the food. Another issue is when you add colors to your products. In some cases, in both glass and plastics, the darker the color increases the migration of elements like chromium, for instance. So another important issue that increases the migration is time, how long the food has been in contact with that material. So there is an interesting study that was done in China when they looked at foods that were bought in different grocery stores, and they looked at them at different times closer to the expiration date or closer to the manufacturing date. So what they saw is that the food that was close to the expiration date had the highest amount of phthalates in it. And the packaging containing the food had the least amount of phthalates. So through times, you go from your starting material that is good, you're losing it, all the pieces of it get into your food, and at the end you have contaminated food and a lousy packaging material. And that happens with time. So another component of this is heat. So I'm sure all of you know that you shouldn't microwave plastic. But heat is also in the microwavable popcorn bags. So anything that applies heat to a material increases the migration of the components of the material into the food. Your coffee cup also increases the migration of substances that are called volatiles or semi-volatiles that come off in the presence of heat. And those substances would get into the food, and we would also breathe it when we are drinking the coffee. So it's through the mouth and through your nose. So that's another reason why not to drink coffee in a plastic cup. So the food composition. So again, the more fat is in the food, the higher the migration of chemicals. As I mentioned at the beginning, most of these chemicals are organic chemicals, so they have an affinity toward fatty foods. The size of the packaging matters too. The smaller the packaging, the more migration occurs because there is a larger surface per volume ratio. So there's more migration in your yogurt cup than in your 25-pound rice bag. The last one is the chemical forces. So when you have rough materials added in high velocity to bags like this that are very common in transportation of cereal or sugar or other dry materials, there is abrasion that occurs in these bags. And these bags are usually lined with an anti-static component that most likely contains perchlorate, that is the rocket fuel. So the perchlorate comes out from the lining, gets into the food, and then is in all of us. So mechanical forces, pressure on the materials also increases migration. So all this is fine. We know the chemicals are there, but so what? There are many people saying, so what? This is a tiny, tiny, inconsequential amount. Including regulators are saying that. Well, there are people claiming that we are making something out of nothing. And it's true. Because chemicals by themselves, in small amounts, may not have a risk, or the risk is very low to human health. But together, they may really increase the risk of human health concerns. And this is the mixture toxicity. We are not dealing with that. As Pete mentioned, we are dealing with one chemical at a time. We are not looking at reality, that is the mixture. So this is of particular concern during times of great development, fetal development, other windows of susceptibility, like the pregnant woman, not just the fetus, puberty, pregnancy itself, the first 10 years of life. The brain is developing in such ways that anything can affect it and have potentially long-lasting impacts and subtle effects that could manifest later in life. So in conclusion, Food packaging, again, is important. We need it. There are, I would probably guess, 80% of the population that highly depend on food that is packaged. We cannot forget about them. I eat packaged food all the time. But there are these chemicals constituents that migrate into the food, and they may pose a risk to human health and also contaminate the environment. So this is my therefore. It is important to select low toxicity food contact materials. It is very important. We need to understand how chemicals migrate so we can prevent that from happening. We can redesign materials to minimize migration. And the last point I want to make is that we need to expand the testing of these materials in the human population, what is called here the biomonitoring. We need to expand the biomonitoring to packaging chemicals to know whether or not these chemicals in packaging are actually migrating out. But it's also important to, hopefully, when these chemicals are regulated in certain ways, we can then monitor whether that regulatory approach is actually working or not. Linda showed yesterday the slides on phthalates. When the phthalates were highly regulated for children's products, for toys, some of them in the human population start going down, but then the replacements are going up. So monitoring for measures like that is very important. And that's all I have to say. Thank you.